domain of a function is my favorite topic whenever I talk about function in class. I have 5 graphs for you. So the first 2 graphs, the first graph I have a parabola, f of x equals to x squared, and then the second graph I have a third degree, f of x equals to x to the third. What is the domain of these 2 functions? So whenever I say domain, you have to think what x value makes the function undefined for x squared and x to the third. What x values? Let's say you plug in an x value, let's say 1 over x. When you plug in x equals to 0, the function is undefined. But can you get an undefined for x squared and x to the third? Think about it. The answer is no, right? So you choose an x value, you either raise that to the second power or you raise that to the third power. So basically any value works. Positive, negative, 0, fraction, decimal, whatever you like. When you raise that to the second or the third power, that always works. So that's why for the first 2 functions, I said the domain is x can be any real number. So x can be any real number. If you don't want to write this sentence, you can just write this r. Do you see this r? This r means x can be any real number. How about the square root function? The square root function is increasing. So for this one, there is a restriction. Square root of x, square root of positive is defined, right? Square root of 4, 9, 10, a million, 6,000, they are all defined. The square root of 0 is also defined, but square root of negative is undefined. That's why when you look at the x-axis, x can never be negative. So on this side, when x is equals to negative, there is nothing because the square root of negative is undefined. So the restriction is x has to be greater than or equal to 0 when you select an x value for this function. So therefore, x greater than or equal to 0 is the domain of the function. How about the cube root? The cube root x can be positive and negative. So by the way, the cube root of 8 is equals to 2. 2 times 2 times 2 is 8, right? The cube root of negative 8 is equals to negative 2 because negative 2 times negative 2 times negative 2 is equals to negative 8. So for cube root, whenever this number is odd, x can be positive, negative, or 0. Whenever this number is even, square root, the 4th root, the 6th root, 8, 10, 12, so on and so forth, x has to be greater than or equal to 0. So less restriction if you have an odd number right in this corner. Now, the last one, the reciprocal function. 1 over x, I get a graph like that. So this one, 1 over x, clearly you don't want x to be equal to 0 because 1 divided by 0 is undefined. So when you draw the domain, you have to take the x out. So there, the ways that I prefer to write the domain is using a number line, using interval, or you use a inequality. So this one number line, I draw a number line, I put a 0 in the middle, and then I put a open circle on top of 0. So now we have 0 in the middle. What kind of number goes to the left? The answer is negative, right? So let's put the numbers right here. So you have negative 1, you have negative 2, you have negative 3, you have negative 4, so on and so forth. And then on the right hand side, you have 1, 2, 3, 4, 5, so on and so forth. So positive on the right, negative on the left. So this one, the open circle means you cannot include 0. Open circle means you have to just take it out. Okay, just take it out and throw it away. So the number line tells me x can be any number in here or here except 0. So when you write the interval, I write parenthesis from negative infinity to 0 and then from 0 to positive infinity. This is an interval. Positive infinity on the right, negative infinity on the left. For inequality, this is x less than 0. This side is x greater than 0. That is your domain. Okay, before we go into some crazy problems, so let's do the easiest one ever. So we have a polynomial. So this is a second degree quadratic function. You can say that. What is the domain of this function? Now think about it. When I ask for domain, think. Can you choose an x value that makes the function undefined? In this case, the answer is no. Because when you pick an x, you square that, you subtract that, of course you can do whatever you want, right? You will never encounter like 0 in the denominator or square root of negative. So for this one, x can be any real number. So x can be any real numbers. Or you can just write this symbol that stands for everything. And then for the number line, so you draw a number line. I will just put a 0 in the middle. If you don't want to do this, that is fine. So x can be everything. So from negative infinity to positive infinity. All right, so that is the domain of the first function. Now, this is not the end at all. I have a few crazy problems for you, and I designed all of them. So this one, we have a lot of problems to solve. Let's start from the easiest one. The square root of x plus 3. Remember, whenever you see a square root, no negatives. So we have to say that x plus 3 has to be greater than or equal to 0. As a result, x is greater than or equals to 3. You draw a number line. Let's say, give myself more space. You draw a number line. You can put a 0 in here. You put a 3 in here. Don't worry about writing all the other numbers out. So x is greater than or equal to 3. So when there is an equal, you use a solid circle. Greater than, so we have a 4, we have a 5 on this side, right? So you shoot an arrow to the right. That is your number line. And then for the interval, so this will be square bracket 3 to positive infinity. Never, never, never use a square bracket for infinity, because infinity, you don't know how big the number is. It is not a number, it's a process of calculation. Again, never, 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 never use square bracket for parentheses. When do we use square bracket? When you use square bracket on numbers, and you use square bracket when there is an equal. When there is an equal, you use a solid circle and a square bracket. All right. So moving on to the next one. The next one, I have the square root in the denominator. So what do we do this time? So whenever you have a square root in the denominator, whenever you see denominator, think this: no 0 in the denominator. Once again, no 0 in the denominator. No 0 in the denominator. So you have to immediately point out that x plus 3 must be greater than 0. No equal. No 0 in the denominator. So x is greater than 3. How about the x plus 5 on top? That doesn't affect anything, because I don't care what's on top. You can have a 0 on top. You can let x equals to 5. I don't care. But no 0 in the denominator. All right? And then you draw a number line. So you have a 3 greater than is this side, no solid circle, because we don't have an equal. So since we don't have an equal, no solid circle, then you use a parenthesis. Oh, 3, huh? Negative 3. Why did I do this? Negative 3. Oh, come on, negative 3. You might be laughing at me the entire time. Negative 3. Okay, I'm going to do this change and then change that. Why do I just mess this up? Negative 3. Okay, so then negative 3 is on this side. Then we have a solid circle. Like that. Okay, then we have a negative 3 all the way to positive infinity. This is a negative 3, so this one will be a parenthesis, negative 3 all the way to positive infinity. We use a solid circle, square bracket, and then in the second problem, we use an open circle and a parenthesis. And never use parenthesis on infinity. Okay, the next one in green, this time you have the x minus 5 and the square root in the denominator. So for the x minus 5, we have to point out that x minus 5 cannot be equal to 0. So x cannot be equal to 5. All right, and then this one is x plus 3 must be greater than, no equal, greater than 0. So x must be greater than negative 3. And then you draw a number line. This is a negative 3, right? This is a 5. So you start at negative 3 and then you go all the way to the right, except you have to dig a hole right over there because x cannot be equal to 5. So you have to use an open circle right over there. So this will be from negative 3 to 5 and then from 5 to positive infinity. All right, doing good. Okay, the blue one. This time we have a square root on top and then x minus 5 in the denominator. So x minus 5, no 0. X cannot be equal to 5. Okay, and then the one on top, we will do a x plus 3 must be greater than or equal to 0. All right, so x must be greater than or equal to negative 3. And then here is the number line. You have a negative 3, you have a 5, greater than or equal to negative 3. And then you take out 5, and then you keep on going. So this is a square bracket, negative 3 to positive 5, and then from 5 to positive infinity. Okay, the red one, they are both in square root. So x plus 3 greater than only, and then x greater than negative 3. How about the other one? The other one is negative x, okay, plus 5 greater than or equal to 0, negative x greater than or equal to negative 5. So when you multiply both sides by negative 1, you have x less than or equal to 5. When you multiply or divide both sides by negative, you have to reverse the inequality symbol. So this one would be negative 3 and then 5. So this is a greater than, but you have to take a stop at 5. This is a solid circle. So this will be parenthesis negative 3 to 5 and then square bracket. All right. So let's move this one up. How about the cube root? So for cube root, in the radicand, we can have positive, negative, or 0, right? So therefore, for this, x plus 6 can be any value. So x plus 6 can be positive, negative, 0. So as a result, x can be any value. So x can be any real numbers. Or you can just draw this. And then for the interval notation is from negative infinity to positive infinity. All right. Okay, we have this one. So the problem is getting crazier. So how about this? We have the square root of 10. You know what? I'm going to move this problem over here. What do we have for the bottom? So for the bottom, we cannot allow a 0, right? So x plus 6, no 0. We cannot allow a 0 in the denominator. So x cannot be equal to negative 6. And then the top negative x plus 10 must be greater than or equal to 0. So negative x greater than 0. Minus 10. And then you divide or multiply both sides by negative 1. So x must be less than or equal to 10. And then this is the answer. So you have a negative 6, you have a 10. So this is a solid circle because we have an equal. And then we show a line. And then we take a stop at 6. And then we keep on moving. So we have a negative infinity to negative 6. And then from 6 to 10. But 10 is a square bracket. Okay. Let's do one more. I didn't prepare that in advance, but we can just do it right here. So how about kx equals to 3 divided by x minus 1 over x plus 2. When you see two fractions, get a common denominator. So this is a x times x plus 2 as the common denominator. The top you have 3 times x plus 2 and then minus x. I don't care what's on the top. I only care this. X times x plus 2, no 0. So x cannot be equal to 0 and negative 2. And then the number line, negative 2, and then 0. Know this, know that x can be everything else. Just know those two values. So from negative infinity to negative 2, and then from negative 2 to 0, and then from 0 to positive infinity. So now we are done. Do you like it? Did I make this clear? If so, give me a thumbs up, give my channel a subscribe, and I will meet you all in the next video. See you there.